So all right, let's go ahead and move on. Move on to 4.6. Now we are in 4.6. And 4.6, we're going to talk about negative and zero exponents. Okay, if you go on to page 201 in your book, there is a negative and zero exponents beige box there. It says, for any non-zero number a to the 0 power is 1. A to the 0 power is 1. So by definition, any number or any variable for that matter to the 0 power is always going to be 1. It is always going to be 1. Okay, anything to the 0 power is 1. Okay, all right. So that's the 0 power thing. Now let's look at the negative exponents. A negative exponent here is basically the negative. So you're going to take, this is the same as 2 to the negative 1 to the 4th. Where the negative 1 is nothing more than a reciprocal. So you're taking the reciprocal here, right? So this is the reciprocal of that 2, 1/2 is the reciprocal of 2, because you're just going and switching a 2 over 1. Now it becomes 1 over 2. Okay, so this is the same as 1 over 2 to the 4th. So 3 to the negative 2 will be the same as 1 over 3 to the 2nd. Okay, so the negative means that you're flipping it over, okay? And then the 2 just comes down here, the 2. Okay, all right, so if I had, let's say that I had 5 to the negative 3, so this would be, since there's a negative here, this would be 1 over 5 to the 3, okay, which is the same as 1 over 5 times 5 times 5, 1 over 125. Okay, all right. So that's the effect that a negative number in the exponent has. Okay, all right. All right, let's see if we can use this to do some of the examples. Let's do example number 1. Example number 1, write the expression using only positive exponents. So we're going to start from here. And so if I use this, so what would this be? Elijah.
It would be 1 over 3 to the 5th power.
Correct. 1 over 3 to the 5th power. Good work. Next one is m to the 0 power, m to the negative 4th. Okay. M to the 0 power is what? What is m to the 0 power? AJ.
Yeah.
M to the 0 power. What is anything to the 0 power?
4.
Nope. Josh, what is m to the 0 power?
1.
1, exactly. So this is 1. It's going to be 1 times m to the negative 4th. So the 1 kind of goes away, right? Because 1 times is the same thing, right? So it's m to the 4, negative 4th. So it is 1 over m to the 4th. Okay? And then we're going to have 16x to the negative 6th. Whoops. And then we have y. Okay, so this is basically the same as 16y times x to the negative 6. So this guy stays the same. Nothing happens with this. Only something happens with this, okay? X to the negative 6 is the same as Pastor. What? What is that?
What'd you say?
What is x to the negative 6?
X6.
1 over
Oh, yeah.
the 6, correct?
Yes.
There you go. So it's going to be 16y over x to the 6. Okay? All right. So hopefully we're getting a feel for this now. All right. Okay. So let's flip the page and go to the next example. Example number 2. Okay, example number 2. Write the expression without using a fraction bar. Without using a fraction bar. So 1 over 16th. So somehow I need to put this into an exponent thing, right? So 16 is equal to 4 times 4, which is the same as 2 times 2. And this 4 is 2 times 2. So it is 1 over 2 to the what power? How many? There are 4 of them, right? So now, without the fraction bar, I have to go and say this is 2 to the what power here? Lissandro.
Sorry, what?
This expression here, 1 over 2 to the 4th, is 2 to the what power?
I don't know.
Grace?
To the 4th.
Negative 4th, right? Negative 4th, right? Because it's in the bottom here, right? That's why it's a negative 4. Okay, negative to the negative 4. Okay. All right, let's do the next one. And we have a squared over c to the 3rd. Okay, on this one, the a squared stays the same. There's nothing we can do with that. Okay. Over here, this is times 1 over c to the 3rd. Okay, so this is going to be the same as a squared. This guy here is c to the negative 3rd. Okay, so again, now I've expressed it without using a fraction bar, right? Okay. So that's example number 2. Let's see if we can do example number 3. Example number 3. We're going to have find the product or quotient. Write your answer using only positive exponents. 5 to the 10th times 5 to the negative 5th. Okay, this is the same as 5 to the 10 minus 5. So this is just a product rule, right? This would be 5 to the 5th. Second one says I have 0.8n to the negative 3rd n to the 2nd. So of course express this using only positive exponents. So I can't say this is -3, -2, then I have -5. So that's no good, right? So I can say this is going to be equal to 0.8. Well, actually, I can just go ahead and do that. Let's go ahead and say n to the, so this is, let's go ahead and use the quotient rule using this guy here, the -3, -2. So I'm going to get a total of 0.8 n to the negative 5th, but I can't use negative exponents, just using only positive ones. So this is the same as 0.8, 1 over n to the 5th, right? Because it's a negative here. Goes down to the bottom, it becomes positive. 0.8 n to the 5th. So that would be your answer there. Okay? All right. All right, last but not least, let's go ahead and do example number 4. Example number 4 seems to be, there's a question there. So Dino, go ahead and read that out for us. Dino, hello? No Dino. Dino's logged in there. He's not with us. All right. Pastor, read the question for us. Example number 4.
Okay. Geckos can easily climb smooth vertical surfaces. Biologists have discovered that tiny hairs are the reason that the feet of a gecko are so sticky. Each hair is about 100 micrometers long. A micrometer is 10 to the negative 16th meter. What is the length of one hair in meters?
Okay, good, thanks. So they are 100 micrometers, okay, where 1 micrometer is, a micrometer is 10 to the negative 6 meters, right? So this is what we're looking at. So 100 is 10 to the second, right? Because 10 times 10 is 100, right? And 10 to the negative 6. So if I do this together, I get 10 to the 2 minus 6 meters. So this is going to be 10 to the negative 4th meter. So 1 micrometer, so 1 hair is 10 to the negative 4th meters long. Okay? So this is also, since it's 10 to the negative 4th, it's the same as 1 over 10 to the 4th, which is the same as 1, 2, 3, 4. So it's 1/10,000th of a meter. Okay? All right? All right. All right, so we're done for that.